Welcome back to freehighschooleducation.com. Today we are going to do chapter 5.7, an exercise session on page 194. Last time when we explained this chapter, we saw that the absolute value inequalities, they translate either into a disjunction or a conjunction. And the best way of solving these is to go back to the definition of the absolute value, which is the distance away from zero. Let's look at number 7 in the written exercises on page 194, and that's absolute 2y minus 8 more than 6. Here, if we apply the definition, we say our number is either in this region or in this region. Here in this region, the numbers are more than 6 units away from 0. Similarly, in this region, the numbers are more than 6 units away from 0. And so we can rewrite this as 2y minus 8 less than minus 6, or 2y minus 8 more than 6. And solve and get the solution, and that will be the solution for this inequality. If we look at number 5, absolute y plus 4 less than 7, here again we can apply the definition, and we find out that our number should be in this region. It is less than 7 units away from 0, and that applies to the numbers in this region between minus 7 and 7. And then we can rewrite our inequality as y minus 7 less than y plus 4 less than 7. And this is a conjunction, as we said previously. Now we would like to solve these problems in a quicker way. So let's go back to number 7, 2y minus 8, absolute 2y minus 8 more than 6. In this way, in this case, we can equate this absolute value to 6 and solve. And that will give us 2y minus 8 equal to 6, or 2y minus 8 equals to minus 6. And we get two values. So here 2y equals to 14 and y equals to 7. Here 2y equals to 8 minus 6 and y is equal to 1. So we have here two values for y when this quantity is equal to 6. I call these the roots for this inequality. This name, the roots, is borrowed from a later on chapter that we are going to do. And it is better to use the same terminology so we don't have to learn too many words. So these are now the roots for this. Even though that this, word the root is not used in this situation, but just to remember, and since we are going to use it later on, it will be easy to remember at this point that these are the roots. We put our 0 here, and 1 here, and 7 here. So the roots for this absolute are 1 and 7, and these are not included in our solution. And when we reach to a point like this where our absolute is positive here, there is no negative sign in front of it, like in this case. When it is positive and completely isolated, and there is a number here, only one number, then we solve it as if it is an inequality. We get the roots, and these in this case are 1 and 7. And when it is more than, then the solution is outside the roots. And this will be the solution for our inequality. If this was less than 6, then the solution will be inside or between the roots. So you have only two situations when you are solving these inequalities. Your solution is either outside the roots or inside the roots or between the roots. And in this case, when it is more than, it is always outside. When it is less than, it is always between the roots or inside the roots. So let's see if these two regions fit. And we can use here 0. 0, we put 2y, 2 times 0, that's 0, minus 8, that will be minus 8, comes out from the absolute as 8, more than 6, that's correct. Here an easy value is 10, so 2 times 10, minus 8, is it more than 6? And we have 20 minus 8, and that's 12, and that's more than 6, so this region is correct. Let's try a value which is between the roots. And such a value, an easy value, is 5, between 1 and 7. So 2 times 5 minus 8, is it more than 6? And we have here 10 minus 8, is it more than 6? Inside we have 2, comes out as 2, and that's not more than 6. So this value is rejected. So our two sets here and here are correct, and this set is wrong. And so we know that our answer is correct. Now let's do another example which we talked about earlier, and that's number 5, y plus 4, absolute y plus 4 less than 7. We make this into an equality, and we solve this inequality, absolute y plus 4 equals 7, and we get the roots. So y plus 4 equals to 7, or y plus 4 equals to minus 7. In this case here, we get y equals to 3, and in this case we get y equals to minus 11. So these are our roots. Here is 0, and we have 3 and minus 11. Since this is less than, then the solution is between these two numbers, between the roots or inside the roots. Now we are going to test our solution set. Let's put 0, 0 plus 4, is it less than 7? And that's true. Now let's put 10, and in this case minus 10 is inside this, so we can use minus 100, which is an easy number. So let's first use 10, 10 plus 4, is it less than 7? And that's not true, 14 is not less than 7, so this is rejected. And if we use minus 100 plus 4, is it less than 7? And that's clearly not less than 7. So this region is also rejected. And this way we can tell that our answer is the correct answer. So with this we come to the end of this session. We hope to see you again.